Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about factoring by grouping. Thanks for coming to my channel. If this is your first time, welcome. I'm thrilled that you're here. I hope you enjoy it. I hope it's helpful. If you're coming back, thanks for coming back. I'd love to have you subscribe to my channel. I love making videos and I'd love your support. So please subscribe. If you want to leave a comment, I'd love to hear what you think. And we're off. Factoring by grouping. We factor by grouping when we have 4 or more terms in a polynomial. So if we're asked to factor, and the polynomial that we're given has 4 or more terms, then your go-to solution strategy should be factoring by grouping. And this is how it works. I'm going to explain it as we go through our first example here. Our first example is example A here, which is x cubed minus 2x squared plus 3x minus 6. So this is how it works. We're going to want to group these 4 terms into 2 groups of 2, because we have 4, so 2 groups of 2 work, right? And then we're going to pull out what's common in those 2 groups. So we'll try to group them in ways that make sense. And when I mean make sense, I mean we'll want to group them, group terms with other terms that have things in common. So for example, let me just tell you right here. So if I said this was group 1, because both of them share an x squared, and then I say, well, this is group 2, because they both share a 3. Well, that would work. I have 2 groups, and once you choose your 2 groups, and as you're doing this, it's kind of a little bit of trial and error, because if you choose 2 groups and then you pull out what's common in those 2 groups from each of them, and what you have left what you have left over doesn't help you, you come to a dead end, then it's not the end of the world. You just go back to the beginning and choose 2 different groups and then try it again. So hopefully we won't have to do that too many times, but it's very possible that we'll have to do that. And sorry, my OCD is really killing me with that bracket looking thing that didn't look like a bracket looking thing. So if we choose this group 1 and group 2, what do we have when we take out the x squared from group 1? So if we take out the x squared, I'm going to put that in red because we're bringing it out. If we take out an x squared from group 1, what's left over? Well, in the first term, x cubed, we took out 2 of the 3, so we're just left with 1 x. And in the negative 2x, we have just negative 2 because we took out the x squared. So kind of went like this. We got rid of the x squared because we pulled it out, and then in this one we got rid of 3 of them and just had 1 left. So we're left with x minus 2. So the hope is that when I pull out whatever is common in group 2, what I have left over is x minus 2. That's our goal. And I'll explain why that's our goal in just 1 second. So in group 2 is 3x minus 6. They both have a 3 in common, so let's pull out a 3. It's a positive 3. And what do we have left over? Well, the 3 came out, so we just have x. And the 6 is negative 6 is 3 times 2. So if we pull 3 out, then we must have a negative 2 in there. So here we have x minus 2. And check that out. This is exactly what we wanted. Once we pulled the common factor from group 1 and group 2, we saw something. It kind of uncovered another common factor. which was the x minus 2. So we can actually pull that x minus 2 out, like so. This x minus 2 is going to come out right here. It's going to come out also here. And this is the same, right? That's what we want. And we can put it out front. X minus 2. And what's left over? We have the x squared term that was out front. And we have the 3 term that was from the second group. And that's it. I might want to write this up here just because it looks a little awkward. So we have x minus 2 times x squared plus 3. And we're done. We've factored this polynomial by grouping. Whoops. So recap on example A. We had 4 terms. We split them up into group 1, group 2. And then we factored out the common items in each of the groups. And we were hoping to have what was left over be the same thing, because that would create something else that was common that we could then pull out again. And that's what we did. And it worked. We didn't have to regroup. So that's fantastic. Let's give ourselves a little more room down here for B. And let's start with B. All right, so example B is x cubed plus 3x squared minus 4x minus 12. So let's just go with the easy option. And let's just call it G1 for short. The first 2 will be group 1, and the second 2 will be group 2. So what comes out of group 1? Same thing. X squared comes out of group 1, just like we did in the first example. Let's pull x squared out of group 1. And what's left over? Well, we have an x plus 3 and group 2. So if this is going to work, when we pull out the common stuff from group 2, what's left over needs to be x plus 3, which, by the way, both of those terms are positive. And as we see in here, negative 4x minus 12, both of those terms in group 2 are negative. So let's pull out a negative 4. Because that's our best hope of leaving something positive that is x plus 3. And what's left over? Lucky for us, we have x plus 3. If you ever want to check this to see, just if you're not crazy, you can multiply back, you can distribute back everything that you just did, everything you just factored, and see if you got back to the original. So lucky for us, same thing, right? That's exactly what we wanted. These are the same. So we can pull them out in front. So we get quantity x plus 3 and quantity, we have an x squared and we have a minus 4. It looks like we're done. At least we're hoping that, right? But the truth is we're not. Because the x plus 3 is okay, but the x squared minus 4 is not done. That is actually the difference of squares. So we can rewrite this as something squared, right? Minus something squared. And the A would be an x, and the B would be 2. So let's factor the last thing. So the x plus 3 comes down. Nothing changes there, but x squared minus 4, we need to factor that. And I have the formula, by the way, here in green. It turns into a minus b, a plus b. So x minus 2 times x plus 2. And now we're done. Done, done, done. Let's do C. See how this goes. So we're looking at it. I think I'm going to keep the same grouping strategy. The first two are going to be group 1, the second two are going to be group 2. And again, you can choose whatever groups you want. You don't have to just do the default first two go to group 1, the second two grow to group 2. There are many different ways to group it, and more than one of them will give you the right answer, often. But this looks like it's going to work for us, so let's see. So in group 1, we have x to the 4th. So the polynomial, by the way, is x to the 4th minus 2x cubed minus x plus 2. And we need to factor that by grouping. So in the first two terms, what's common is an x cubed. Let's pull out an x cubed. And what's left over? An x minus 2. Let's look in the second one. If we want this to work, again, we're going to have an x minus 2 left over once we pull out whatever's common in the second group. And when you look at the second group, there's nothing common, right? Negative x and plus 2, they don't have anything in common. But it looks a lot like the x minus 2 that we're looking for. It's just a negative of it. So why don't we plot a negative 1? If we pulled out a negative 1, then that would change the sign of the negative x plus 2 and give us a positive x minus 2, which is exactly what we're looking for. So that common thing now that is the same, right? We like that. We're going to plop it out front, and we get x minus 2. And what's left over? Well, we have x cubed that comes from the first term, and we have a negative 1 from the second term. And again, we think we're done, but we're not. So let me just rewrite it. X minus 2 quantity times quantity x cubed minus 1. The x minus 2 is fine. We can't do anything with that. But the x cubed minus 1, that looks like the formula directly above it, which is the difference of cubes. We can rewrite this as something cubed minus something else cubed. So actually, I'm going to move that down a little bit. So I have something cubed minus something cubed. The something in the first spot is x. The something, so that's a. So a is x. And 1 is b. So that makes it a little bit helpful. Because we can just literally write out the answer now. We just use the formula, plug in the a's and the b's, and bring it down. So the x minus 2 is carried down with us, and the x cubed minus 1 is going to be rewritten because it can be factored, and it'll be a minus b, so x minus 1, and a squared, so we have x squared, plus a times b, that's x times 1, which is just x, plus b squared, b is 1, so 1 squared is 1. And now we are done. Forgot to put equal signs above. All right, not bad. Not bad. Factoring by grouping isn't too terrible. Sometimes it takes a little bit of extra time, like this next one. We're going to have to use the difference of squared and the difference of cube formulas, but it can be done. All right, so we're looking at the we're looking at this problem. This problem is example D, and it is 2x to the 5th minus 8x cubed minus 2x squared plus 8. I see a lot of 2's and negative 8's, or 2's and 8's, alternating signs. Let's stick with our grouping that we've been doing, except for that's supposed to be red. So we have group 1, and we have a group 2, which would be the second 2. So in group 1, we can pull out a 2x cubed. Actually, you know what we should do? Before we do any of that, let's pull out a common factor here. There's a 2 here, right? Let's pull out a 2. You should always check to see if you can pull out a common factor from every term before you start to simplify things. And I forgot to do that, so let's do that right now, because you can see everything is divisible by 2. So this would give us then x to the 5th minus 4x cubed minus x squared plus 4. All right, now let's put back in our group 1 and group 2. So x to the 5th minus 4x cubed is going to be group 1. And group 2 will be negative x squared plus 4. All right. The 2 will just continue down. And out of group 1, we can pull out an x cubed. So let's do that. X cubed, and what's left over? X squared minus 4. And in our second one, they don't have group 2 has nothing in common, so let's just pull out a negative to make it fit the x squared minus 4. So we pull out a negative 1. Then what's left over is x squared minus 4. That's great for us, right? Because we see the commonality. It's the same, so we can pull it out. We can pull that same thing out in front, and we have x squared minus 4. And what's left over? We have an x cubed, and we have a minus 1. And we can't forget our 2 that's hanging out in front. Now, as we look at this, a couple things come to mind. First, this is the difference of squares. And this is the difference of cubes. So we need to identify the A and the B for both of these situations, and then we can write down the answer. I'm going to move these two down a little bit. Here we go. So the first one, can we rewrite this as something squared minus something else squared? That's our hope. And for the second one, can we write this as something, something cubed minus something else cubed? And again, we have our 2 hanging out front. Well, I think x will be a, and then b will be 2, because 2 squared is 4. When we're doing this for the second formula for the difference of cubes, we have x again as a, and luckily we just get 1 as b. So now we've identified a and b for the difference of squares and the difference of cubes. We can just literally write out the answer. So let's do that. And remember, we have a 2 hanging out in front of us, but we're now doing the difference of squared. So we have x minus 2, x plus 2. There's the difference of squares. And the x cubed minus 1, so the difference of cubes, we can write that out too. That formula is a minus b, so x minus 1. And then x squared. And then a times b would be x times 1, which is just x. And then plus 1 squared, which is 1. There we go. We're done. So we had the difference of squares and the difference of cubes on that. And we had a common factor we had to pull out at the very beginning. Last one, last example. This one looks kind of nasty because it just has variables. There aren't any numbers. But it's okay, this one actually is the easiest. Let's, again, say this is group 1. Again, you can choose whichever groups you want. And you can still have stuff that you can still have it work out. All right, so group 1, we can pull out the x. So let's do that. What's left over? A plus b. And in group 2, we have, let's pull out a negative y. And we have a plus b. That works. It's exactly what we want, right? Because this is the same, we have a common factor we can pull out. So we have a plus b sitting out front. And we have an x left over and a negative y left over. And we're done. So our answer then is a plus b and x minus y. So that looked not fun, but it turned out to be not that bad. Hopefully this was helpful. Thanks for watching.